The mountain does not look like a fortress. From the road outside Colorado Springs, Cheyenne Mountain is just a peak. Granite, pine trees, silence, nothing announces what is inside. But somewhere beneath 2,000 feet of solid rock, a city is running. It has been running without interruption for more than 6 decades. Most people have never heard of what keeps it alive. That is by design. Cheyenne Mountain Complex was not built to be discovered. It was built to survive everything else being destroyed, and the engineering required to make that possible pushed the limits of what mid-century construction had ever attempted. The story begins not with blueprints, but with fear. In the early 1950s, the United States military faced a problem it had never confronted before. Soviet long-range bombers could now carry nuclear weapons across the Arctic and strike the American interior with little warning. The radar networks that existed at the time were too slow, too fragile, and too exposed. A single well-placed strike could blind American air defense at the moment it mattered most. The solution required a command center that could not be blinded, one that would survive a near miss from a nuclear weapon and keep functioning. They chose a mountain. The North American Aerospace Defense Command, NORAD, had been established in 1958 as a joint American-Canadian operation. Its mission was to detect and respond to any aerial threat approaching the continent. For that mission to work, the command infrastructure had to be indestructible. Cheyenne Mountain was selected as the site in 1959. The logic was simple. 2,000 feet of granite absorbs blast force that would flatten any surface structure. You cannot vaporize a mountain. Construction began in 1961. The project required hollowing out the interior of an active mountain, a task that at that scale had no clear precedent in American engineering history. Workers drilled and blasted 15 tunnels into the granite. The main chamber alone stretches nearly 600 feet long and wide enough to house a football field. Crews removed nearly 700,000 tons of rock. They did it in less than 3 years. But removing the rock was only the first challenge. The real engineering problem was vibration. A nuclear detonation close enough to threaten the facility would send shockwaves through the granite that no rigid structure could survive. The force would not come as an explosion through the entrance. It would come as movement through the rock itself. The solution was to make the buildings inside the mountain float. 15 freestanding steel buildings were constructed inside the main chamber. Each one sits on enormous springs, more than 1,300 springs in total, each spring roughly a meter in diameter. The buildings are not bolted to the floor. They rest on those springs, isolated from the rock around them, capable of moving more than a foot in any direction when the mountain shakes. The tallest buildings inside reach 4 stories. They are connected by flexible corridors that move with the vibration rather than resisting it. Every pipe, every cable, every duct entering or leaving those buildings passes through a flexible coupler designed to absorb shock, not rigid, not braced, floating. The springs themselves were an engineering marvel. They were designed to absorb a specific frequency of blast wave, the kind produced by a nuclear weapon detonating within a defined distance. Engineers tested and retested the resonance calculations. If the springs tuned to the wrong frequency, they could amplify vibration rather than absorb it. The margin for error was measured in lives. By 1966, the complex was operational. The price tag at completion was reported at around nearly $200 million, equivalent to well over $2 billion in today's terms when accounting for decades of maintenance, upgrades, and the classified systems installed across the facility's lifetime. The blast doors weigh 25 tons each. There are multiple sets of them, designed to seal within seconds. The walls at certain points are reinforced with steel and concrete several feet thick. The ventilation system can be sealed completely and shifted to filtered internal air within moments of a chemical or biological alert. The facility has its own water supply, its own power generation, enough stored fuel to run independently for 30 days without any outside resupply. It was designed to be the last thing standing. And then, something the original designers had not fully anticipated began to change the calculation. For the first 20 years, the primary threat model was bombers. Slow, trackable, interceptable. The facility's warning systems were built around radar networks designed to detect aircraft crossing the Arctic approaches. But missiles changed everything. Intercontinental ballistic missiles travel not through airspace, but through space itself. They follow ballistic arcs that reach hundreds of kilometers above the Earth's surface before plunging back down at speeds exceeding 20 times the speed of sound. A bomber gives you hours of warning. A missile gives you minutes. The inside of Cheyenne Mountain had to evolve. Through the 1970s and 80s, the complex was continuously upgraded to track not just aircraft, but missiles. First Soviet ICBMs, then submarine-launched missiles capable of approaching from any ocean. The sensor networks feeding data into the mountain grew to include satellites, early warning radars positioned around the globe, and signal intelligence systems of a classified nature. At peak operations, the facility employed more than 1,000 personnel. They worked in rotating shifts around the clock, every day of the year, tracking every object of concern in the airspace and near space around North America. The tension that defined daily life inside that mountain is difficult to describe to someone who has never worked there. Every alarm was real until proven otherwise. Every unexpected radar return demanded immediate analysis. On at least 2 documented occasions, in 1979 and again in 1980, computer errors triggered warnings that appeared to indicate a Soviet missile launch was underway. Personnel inside Cheyenne Mountain had minutes to assess whether the signals were real. They were not. The errors were traced to faulty equipment and software failures. But for those minutes, the people inside that mountain were among the few on Earth who knew what appeared to be happening and what the response would be if the signals were confirmed. That wait was constant, quiet, unacknowledged in most public accounts of the facility. By the early 2000s, questions began to emerge about Cheyenne Mountain's future role. New threats, cyber attacks, asymmetric warfare, terrorism did not require the same hardened command infrastructure that nuclear deterrence demanded. The facility was expensive to maintain. Its systems, while upgradable, were aging. In 2006, NORAD announced it was shifting day-to-day operations to Peterson Air Force Base, located nearby at lower elevation and without the mountain's protections. Cheyenne Mountain was placed on warm standby, maintained but not fully staffed, capable of reactivation within days if needed. The move was presented as a cost-saving measure. It saved an estimated $200 million over a decade, but the mountain did not go dark. In 2015, the United States military announced it was returning significant operations to Cheyenne Mountain. The reason given was electromagnetic pulse vulnerability. Modern electronics, including the command systems at Peterson, are susceptible to the pulse effects of a high-altitude nuclear detonation, which can disable electronics across a wide region without a single direct strike. Cheyenne Mountain's age became its advantage. The Faraday shielding built into its infrastructure decades earlier, designed to protect against nuclear effects, also protects against electromagnetic pulse. The mountain's systems are hardened in ways that newer facilities are not. 2,000 feet of granite, as it turns out, does not go obsolete. Today the facility operates in a capacity that the military does not fully disclose. What is publicly confirmed is that it remains part of the NORAD mission infrastructure, a fallback, a redundancy, a last resort if the more modern and more convenient facilities above ground are compromised. The springs still function. The blast doors still close on schedule during regular tests. The water reservoirs are maintained. Somewhere beneath the pine trees and the granite, systems are running that most Americans will never think about, in a place designed specifically so that no one ever needs to think about it. That is the point. The engineers who hollowed out that mountain in the early 1960s were not building a monument. They were building a guarantee, a physical promise that the machinery of response would survive whatever came first. The logic was cold and precise. It was also, in its way, a form of hope. If everything else failed, the mountain would remain. It still remains. Whether the threats it was built to survive are the same threats that define today's world is a question that strategists continue to debate. The nature of deterrence has changed. The nature of warfare has changed. But the mountain has not changed, and the question of what it means to make something truly indestructible, that question has not changed either. The story of Cheyenne Mountain is still being written. The next chapter depends on decisions not yet made and threats not yet named. The mountain will wait.